Welcome everyone to another episode of FIRST Canada Live. Hope you had a great weekend. Good morning, good afternoon. I am your host, Karthik. Glad to be here with you for what should be another great show. I'd like to introduce our co-host, second time co-hosting. We have Param from Team 4946, the Alpha Dogs, Dean's List winner at the championship last year. Param, how are you doing, man?
I'm doing absolutely fantastic. I'm really pumped to be back on the show. Second time is going to be absolutely great. We've got a great lineup I'm super duper excited for. And how are you doing, Karthik?
I'm doing great. Had a weekend to recharge, but I'm ready for some more FIRST Canada Live action. So, Param, you've been watching every episode, and the Youth Council's been really big as a instrumental part of this show. What have you enjoyed the most so far? Was there one segment that really stood out to you?
Well, I think it's just been incredible hearing from so many different people who have been involved in FIRST in so many different capacities. And you get to hear from all these mentors, these alumni. And one segment that really stood out to me as being something super cool that I think everyone should watch was the segment that we did with Jeff Lee, who's actually on FIRST Canada board, which was a super unique insight into what that was like. And that's something you don't really normally get to see when you're just in the day-to-day of competition, which is something that I really enjoyed. And I think everyone should check out that episode.
Yeah, and all our archives are available on FIRST Canada's YouTube page, so go head on over there and take a look, But we got a really good show today, too, and I think we might be able to top some of the ones in the past, because, listen to this roster of guests we have. We have Libby Kamen, lead mentor from Team 1923 and FIRST Personality, so that's going to be fabulous. We got two great team showcases. We got Team 7558, Alt F4 from Toronto coming on. They're a robot this year. Did you see it up close, Param?
I actually did. I was lucky enough to make it to Humber for that one day, and oh my gosh, I must say, one of the most beautiful robots I've seen this season, and I'm super duper excited to have them on the show this time.
Yeah, and for a second-year team especially,
exactly.
To come out out of the gates like that. We got a FIRST Canada program showcase today on FIRST LEGO League. We've talked a lot about FIRST LEGO League. Almost every one of our guests has actually been a FIRST LEGO League alum. So we're going to hear all about FIRST LEGO League, what the program's like, what it takes to start a team, what it takes to run a team, and all that goodness. We got a great panel to discuss that. And on our first segment, we have World Championship finalists last year from Detroit. They're at the Detroit Championship in Detroit. They're actually from Hamilton. Team 5406 Celt-X with a team showcase of their unrevealed robots. So that's going to be really good. So just a reminder to everyone, if you got any questions for myself, Param, any of our guests throughout the show, drop them into the chat. We'll do our best to get to them at some point. And also, just keep in mind that the whole point behind FIRST Canada Live is to bring some positivity and some energy to our community right now. So let's make sure we keep our comments positive and, of course, graciously professional. But I think now it's time to get started with our first segment. So I'd like to welcome in Team 5406 Celt-X from Hamilton, Ontario. They've won 6 blue banners in their history, including, as we said, in 2019, the Archimedes division at the championship, and they went on to be championship finalists, coming as close as you can get to winning the championship without, I guess you could lose on a tiebreaker. That's another story we don't even want to get into right now. So I'd like to introduce from Team 5406, we have Victoria, Emma, and Andrew. Hey, hello, how are you?
How are you doing, Carson? Amazing.
Thank you so much for being on the show. Thanks for and agreeing to showcase your robot. Also, everyone, Victoria is kind of a big deal in the FIRST community. She is the artist behind FRC Doodles, the comics that have gone viral on Instagram and beyond. So I hope we get to see a couple doodles maybe in the presentation in there somewhere, tucked in there. Maybe, Victoria?
We'll see, Karthik.
All right. So how about you just take it away? Show us what you got.
Great. So who are we? As you might have heard, we are Team 5406 Celt-X from Hamilton, Ontario, Canada. This was our 6th year as a team. Our rookie year was in 2015. And each year we continually strive to perform at the highest level while embodying the spirit of gracious professionalism and assisting the teams around us to the best of our ability. We are the stewards of the Robodrome, and we also co-host the Stanley Cup Championship.
Okay, so hi, I'm Emma. I'm in grade 11. I work on design and manufacturing, and I'm also the operator. So this year, our team had 2 main competition season goals. Every year, our goal is to be one step further than we did in the previous season. And last year, we actually did have a goal to make it to Einstein's. Not a lot of people know this, but after Ontario District Champs, I decided that we were going to win Worlds, and nobody took me seriously until we almost made it there. Unfortunately, we didn't, but that became a goal this year. To field the most competitive robot we could, we also have a goal to have 0 on-field breakdowns. We do this by systems checks before every single match to make sure we don't miss anything and our robot is running as smoothly as possible. We go on to the next slide, please.
So the workspace that we build out of is the Robodrome, which is a shared build space given to us by our board. It's outfitted with a full machine shop and a nearly full-size practice field. So we worked closely with the school board to outfit the Robodrome and to shape it what it now is today. We secured grant money and outfitted the machine shop with a bunch of complex machines. Like we have a CNC mill, we have a router, we have a laser cutter, stuff like that. Since this building is a shared board building, it serves as a workspace for the multiple FRC teams in our board. However, we invite teams from all across Ontario to come and practice with us and use our facility. All we ask of them is for them to bring us a team shirt, and we will display that on our t-shirt wall. And as of now, we've collected over 20 t-shirts. So that's just absolutely amazing. Something we hosted for the very first time this build season, or rather first week of competition season, was an event called First Aid. And this was an event where rookie teams or any team that needed a little bit of extra help before competition, we invited them to come to the Robodrome, and whatever they need help with, mechanical, software, electrical, stuff like that, we help them out and try to get them up and running.
Victoria, one question for you. You mentioned that you have all that machinery there, that non-board teams can come to practice the Robodrome. Are they allowed to work on their robots on the machinery, or like can they make parts there with your supervision? Or
so we have a mentor in the shop at all times. So they supervise when people are using the tools. I'm not sure if they're allowed to use the more advanced tools. Give me one.
Okay. Just curious, I'm sure that some of the teams out there, might not know about this opportunity and would love to, especially if there's machines that they don't have access to at their own school. That'd be a great opportunity for them.
Yeah, we definitely encourage teams to ask for help when they need it. For the bigger machines, if you're not trained, it would probably be one of our teammates helping make your part, just for safety reasons. But yeah.
Either way, that's a great option for teams. So thank you for doing that.
Hello, I'm Andrew, also in grade 11. I do mostly mechanical and design. And going into build season, our main strategy is to first figure out all the rules in depth about this year's game and how it can be played. In order for us to be able to then try and figure out every single possible play or cycle that robot can perform during a match. And then try and figure out how valuable that cycle or play could be based on how much time it take, how many points it get us, and then how difficult it will possibly to do that.
And in order to do this, we also have a human game to make sure we understand it fully. And we have 3 tiers of robots. Our teammates act as robots. We have the Brave Little Toaster, an average Ontario team, and a World Championship winning team. And we figure out how they would affect their alliance scores and what kind of robots they would be and how they would play the game. This year, we estimated an average game would be around 80 to 100 points, and we hoped by the end of the season, we could contribute 150 to 200 points to our alliance. Can we go to the next slide, please?
So as a team, we do a lot of prototyping. We don't like to go from simply CAD to robot, that's it. We CAD a lot of our prototypes, and we test them out, then we go back and CAD them until we finally come up with something that we feel is ready to build and will be good on the robot. So 3 things that we prototyped that did not end up on the robot that were scrapped were the buddy climb, the linear shooter, and the pop-up. So the buddy climb was something that really worked well for us in 2018. And the reason we wanted to do a buddy climb in 2020 was for RP assurance. So RP assurance is where we want to ensure that every match we get that climb RP, which worked well for us, really well for us in 2018. But the buddy climb was scrapped in 2020 because it simply did not package well, and we just didn't have enough weight.
One of the main decisions we had to make for this year's robot was whether we were going to have a linear or hooded shooter, and we prototyped a lot with the linear shooter. It was fairly accurate, but but ultimately we decided to go with a hooded shooter because it was much more consistent for how we wanted to play the game. So if we could play the video. This was on, I think, day 4. It was the first time we got a power cell in the inner port, and then by day 5 we were prototyping our hooded shooter.
So the last main
Could we go one side back, please?
So one of the last main things that we prototyped was mounting our shooter on top of a lifting mechanism in order for our short robot to be able to shoot over top of the control panel into the power port. After further design, we realized it was a bit too difficult for us to fully incorporate into our robot. As well, it was a bit heavy and we did not have the weight for it. So we decided to go with a simpler option of just driving under the control panel a few more feet to get similar time shots.
So this is our reveal video for this season. We named our robot Mo because it looks like the microbe obliterator from WALL-E. And there's a little picture there. Show.
So that was our 2020 robot, Mo, and we're just going to be going through Mo and talking about some of the mechanisms that can be found on Mo, except for the color wheel spinner, because that didn't quite make it on in time.
Victoria, I want to just share one comment we have from chat. I thought you named your robot after the superintendent from the HWCDSB who's responsible for robotics and STEM. And that comment is from none other than your superintendent, Morris.
Thank you.
I think it's a pretty good story. I think you should go with that one.
Oh, man. Okay,
Okay, so this year's drivetrain is a 6-wheel single-speed West Coast drive. It has Flip Neo custom gearboxes, and our gearboxes and rails were made on our CNC router.
so Danny demanded this year that we have base lock since it's a shooting game. If you're not familiar with what base lock is when you set the wheel PID to continually correct for the last position that you were in. So if you get knocked around a little bit, the wheels will continually try to correct to where the position you were last in. So basically, the drivetrain is locked. This is useful for shooting and to combat defense. You don't want to get your shot messed up while getting defended. So base lock is just a way to combat that. Next slide, please.
Our goal when designing the intake was to be able to make an intake that can efficiently pick up as many balls as it can in a short amount of time. And what we came up with was a full width intake that can pick up 3 power cells at once. It is cut out of HDPE plates that were laser cut in-house and feature custom 3D printed pulleys that are mounted on our rollers. as well, our intake moves in and out using pneumatic cylinders and bearing sandwiches, which allow our intake to extend out and intake from the loading station.
So we pulse the rollers while we're shooting for two reasons. One, so the balls don't get jammed, they get to shuffle around a little bit. And second of all, our hopper is just gravity. It's slanted into the robot, but there's nothing actively pulling on the balls to push them deeper into the feeder and into the turret. So we need to pulse the rollers to push the balls back there.
I just wanted to mention a point that was brought up in the chat. It says this was the most redesigned part of the robot. Want to shed some light onto why that was?
For the most part, it was trying to make sure that all the power cells weren't getting jammed. A lot of our original designs had an issue of power cells jamming on the side parts of our intake where it leads into the hopper, as well as being able to efficiently get them through the hopper into our shooter. So we had to spend a good few weeks just constantly redesigning and making minor changes to it. At first, when designing our hopper, we decided to test out using brushes. And after multiple attempts of trying to get them to work the way we wanted them to, they were slowing us down quite often, as well as sometimes the power cells would get jammed in between the brushes. So we decided to remove them in our final design as we were able to run without them.
And in order to avoid jamming power cells when we were feeding them to the turret, one side of our serializer actually spins 10 times faster than the other, so that one ball is being pulled in at a time.
So our feeder is actually two parts. It's a wheel that pulls the ball in from the serializer, and there are also powered rollers that prevent jamming. It used to be a Lexan sheet, but the balls like to stick to the sheet and each other, so powered rollers just prevent them from doing that. And our feeder is also velocity controlled. We don't pass the balls when the flywheel isn't spinning up or it isn't actively powered, because then it just jams. And we also have a security mechanism where we limit how quickly the balls are passing through the turret, and it's velocity controlled, so it limits the max RPM rate.
One. That one had like a bit of...
So the cool thing about our turret is it's basically all made in-house. We have the delrin on the sides is laser cut. The aluminum plates at the bottom are made on our CNC router, and we have the motor controller and limelight mounts that are 3D printed. We have about 300 degrees of rotation and about 90 degrees of hood motion.
So the turret has the coolest software stuff by far, I think. So we have two absolute encoders, one on the turret itself and one on the hood. So if we brown out or lose comms for a moment, then we can always find our zeros, and we can find our zeros from any arbitrary location. We also have auto targeting with the limelight. We have a quadratic regression, so we can find the hood angle and RPM of the flywheel from anywhere on the field using the TY value from the limelight. And we also installed soft limits. So we have about 300 degrees of rotation, but that's probably a conservative, it is a conservative number, because we installed the soft limits to make sure we don't break our umbilical while we are turning the turret. So yeah, it's worth noting that we could actually like turn 360 degrees if we wanted to. It's just a matter of us like extending our umbilical, because in our practice spot we can turn 350 degrees. So that's something cool about that. Next slide, please.
So originally we had two individually powered linear bearing arms, but they didn't package well, and they were kind of on the heavy side. They weren't working the way we wanted them to. So instead we have a virtual 4-bar linkage, and it's actually powered by only one Neo because we ran out of motors on our robot, and it locks with a bicycle brake, which we took from our 2015 robot.
So we actually have an automated climb. Oh, do you want to play the video? Okay, so we actually have an automated climb where the driver just has to line up to the switch and then press a button, and the arms go to go to an arbitrary height. Then the operator from there can adjust the arms and press another button and we're climbing. So that's our automated climb, but we also have a manual climb just as a backup. This is also to achieve our goal of 0 on-field breakdowns. It's good to have the manual just in case the automated fails for some reason. So here are a bunch of electrical things that we think are cool and really want to highlight. So in 2018, we stopped using Anderson connectors on our CAN because we used them out of spec, and that caused 2018 two different failures. One of them was our 2018 robot Tipsy throwing a cube over the driver station wall. So we didn't want that to happen again because there was a wire break in the Anderson, in the umbilical. So we switched to IDC connectors, which are in spec for CAN.
Yeah, so our umbilicals, we have 2 on our robot, 1 going up to the turret and 1 on our intake, and it's just a nice way to keep all of our cables together and organized. We also use DIN rail on our belly pan and with custom 3D printed mounts that just clip on. It's really easy. In between matches, if something's broken, we can fix it right away.
We stopped using PoE on the Limelight because it introduced more points of failure. You could lose the Limelight if the Ethernet was just slightly off. So we found that wiring straight to the PDP was a better solution.
Yeah, and we also have an Ethernet switch just to further that 0 on-field breakdowns so that nothing has to be unplugged when we tether on the practice field. And we used terminal blocks this year because 15 slots on our PDP were used by motor controllers and we still needed to power the encoders in Limelight. Can we go to the next slide, please?
So through the terminal block, you're able to power the Limelight and the encoders all. How's that set up?
The encoders are on the terminal blocks. The Limelight is in the PDP.
Okay.
Yeah.
So, and the terminal block goes to the VRM?
I think it's wired straight to the PDP. I could be wrong on that though.
But which slot on the PDP?
The 16th one.
So the Limelight and the terminal block are going to the. I'm just trying to capture how you're getting all of that into the PDP. Is it all going into one slot on the PDP, or?
It's going into the terminal block, which goes into the PDP.
Okay, so the Limelight's not going directly to the PDP. It's going to the terminal block.
I'm pretty sure, yes.
Okay, cool.
So our design goal for autonomous this year was we wanted a path following program that could get us a reliable 8 and more ball auto. In 2018, we had great path generation, but terrible path following. And in 2019, we had terrible path generation, but great path following. So this year when WPI Lib released the Ramsey controller for path following, we decided that was the best of everything and we wanted to use that. So we used the Ramsey controller for path following and trajectory generation. We use the new encoders that are on our drivetrain and the NavX. We utilize sequential and parallel commands to make sure we're making the best use of our time and not idling in places where we don't need to be. And sometimes we utilize driving while shooting. It's not in this video. This video is our 8-ball auto, but we utilize it in our 7-ball, and these were starting points implemented just so we could see whether it worked or not. And it does work. We wanted to use it later for 9 and 10 and that kind of auto, but it never happened because the season ended. So this is our 8-ball auto.
So just going back to the electrical for a second, you talked about how you stopped using Anderson connectors because they're out of spec for CAN. What spec is this? I think this would be a really cool thing for our audience to know if teams are actually using Anderson connectors incorrectly.
I think if I remember correctly, I think Anderson connectors are too large for what we were using for.
Too large according to what though? Like
The
just
gauge of
too
the
large.
wire.
Yeah.
So the gauge of the CAN wire was too small to be using on Anderson's.
There we go. Okay, cool. So you stopped using Anderson connectors just on your CAN wires, not like across the robot.
Yeah,
You still
we
use them for
still
other
use
electrical
them. We just
connectors.
use IDC on the CAN.
IDC on the CAN. Okay.
And here we've got a question from the Twitch chat. Why did you decide to use Omni wheels if you already have a center drop from the West Coast drive? Does it, help with the turning even more, or did you find that it wasn't enough to just have the drop?
Yeah, it helped with the turning. So the Omni wheels actually got quite destroyed on the rendezvous point, but it was very helpful for controlling how we turned, especially when there was a lot of power cells on the field and we only wanted to be picking up 5. So we found that it was better for control.
How much drop did you have this year?
An 1/8 inch.
Okay, cool.
And
That's
how was your hood powered? Just a quick question.
Pardon? Sorry?
So how was your hood actuated? Was it just pneumatically, just 2-position, or was it fully adjustable?
It was fully adjustable. It was gears custom cut on our laser.
Cool.
That's just a fabulous robot. It's another one of these robots that we see on the show where it's just like, man, I really wish I got to see it play. And I hope we will have that opportunity at some point. Stanley Cup, hope the world is more under control and we can do this and we can get back to playing robots, because that would be amazing. And this is one of those ones that I just really, really want to see on the field.
Yeah.
For you, Celt-X, what was that feeling like when you found out that the season wasn't going to happen?
It was definitely upsetting. I was looking forward to competing. I know it's kind of out of our hands. I just hope that we eventually get to end up playing with the robot.
And are any of you seniors, or grade 12s rather?
We're all in grade 11.
So you're all back for another one.
Yeah.
All right. Before we go, is there any last thing you want to tell us about your robot, about your team? Any shout outs you want to give?
Thank you, Mr. Hootzel, for watching.
Yes.
Let's go, Mr. Superintendent.
Well, I have to